Work and energy are things we talk about all the time in the context of our daily activities. However, in physics, we have a very precise meaning for work and a very precise meaning for energy, which often do not have the same connotations as what we use every day. Work is the actual process of changing the energy of a system. In mechanics, in order for this to happen, there must be a force applied over some distance. Say we move an object from point A to point B. We know it travels a certain distance, and we know it takes a certain amount of force to move it that distance. The total amount of work done is equal to the force multiplied by the distance in meters. The label for this is sometimes written as Newton meters, but you will also see it written as a joule. Remember that forces have magnitude as well as direction, so they fall under the vector category. As such, we need to take into account any angles that may arise with our motion. Take a guy mowing the lawn. He applies a force to the mower in a horizontal direction, but since the handle is actually at an angle to the motion, the force acts in that direction. So we have to find the component of that force acting in that direction. By looking at the angle the applied force makes with the direction of motion, we can determine that component by multiplying the force by the cosine of the angle. So our work equation to include force at an angle becomes the force times the distance times the cosine of the angle. We can look at the other examples given in the text and apply this formula as well. A man holding a briefcase exerts an upward force on it, but since it is not moving, there is no work done. Now you might argue that if you hold the briefcase long enough, you start to get tired. This would imply some work is being done. The answer lies in what we have defined as our system. You have all kinds of muscles that are doing work against one another to keep the briefcase where it is. So there is work being done, but it is not being done on our briefcase. Once he starts walking with the briefcase, he moves it in some horizontal direction. The force is still being applied upwards, which makes it occur at a right angle to the direction of motion. Math savvy among us will note that the cosine of a 90-degree angle is 0. What this means is that there is still no work being done on the briefcase. This might seem counterintuitive at first, because the briefcase is in fact moving. However, the force that we have defined at this point is not what is causing the motion. Now what if we walk up the stairs? Now that force we are applying has some component to the direction of motion. So we look at the angle of the motion and determine how much of that force is going into causing that motion. So how much work is being done on the lawnmower in figure 7.2? The guy exerts a constant force of 75 newtons at an angle of 35 degrees below the horizontal for a distance of 25 meters. This one is pretty straightforward in that we know our force and distance along with our angle. So we just need to plug into our work equation, and we get 1.54 times 10 to the third joules.